Hi everyone, welcome to our latest Coolest Projects webinar. My name is Nick Crofts, and this week we are looking at making mobile apps with MIT App Inventor. Thanks for joining us. This week I've got David Petty with me, who works on the MIT App Inventor. David's actually got some demos today, so he can help you get started making your very own mobile apps. So if you want to make something that uses the sensors on your phone or maybe controls a robot that you've built, this is a great place to get started. But before we dive in, I just want to take a moment to talk about Coolest Projects itself, what it's all about, why we run it, and how you can take part. So what is Coolest Projects? Well, it's a celebration of you and all the brilliant things that you guys are making with technology. Anyone up to the age of 18 can enter. We've got an online showcase, so you can enter no matter where you are in the world. We've also got some in-person events, which I'll talk about in just a second, and registration is open now. Okay, how does it work? Well, you can make a project in one of our 7 categories. Today, we're going to be doing mobile apps. We've also got a new AI category this year. So if that's something you're interested in, please take a look on the Coolest Projects website at that. We work on projects at all levels, whether you're a beginner or an experienced coder. And we also accept projects that are still work in progress. So if it's not complete, don't worry. As long as it involves code and you're proud of it, it's perfect for Coolest Projects. So there are 2 ways to get involved. The first is our big online showcase. Follow the link on screen to have a look at projects from previous years. Young people from anywhere in the world can share their creations here. And if you enter online, you'll get feedback, a certificate, and there's a brilliant live stream where we highlight loads of fantastic projects. Last year, we saw over 4,000 projects from over 7,000 young people in 43 countries around the world. So it's truly global. The second way to enter is through our in-person events in selected countries. You can check out which ones are running and how to join on our Take Part page. Just follow the link below this video. Some of these events have happened now. We've had Coolest Projects USA, Coolest Projects Belgium, Coolest Projects Ireland went down terrifically, and registration for Coolest Projects UK has now closed. But as you can see, there are many more events around the world, so follow the link and see if there's one in your area. If you've missed it this year, don't worry, you can still submit to Coolest Projects online and then try again for the in-person event next year. Okay, I think you've heard enough from me now. I'm going to hand over to David, and he's going to give you a quick introduction into the MIT App Inventor so you can get started coding your own mobile apps. Over to you, David.
Hello, thank you very much. I'm going to be talking today about MIT App Inventor, and it is a mobile app development platform that allows us to develop apps for iPhones, iOS, and Android mobile devices. The resources are available in this presentation. There's a short link and a QR code there. Feel free to refer to anything that you see in this presentation. This is what we're going to cover today. What is App Inventor, how to set it up, and how to make apps. And in the second part, we're going to dive into some of the interesting apps and components that exist within App Inventor for you to work with. So what is MIT App Inventor? It's a free and open source web platform that connects a browser to a mobile device and allows you to generate apps using all of the resources on your phone. It's a full computer language that allows you to do all of the things that a modern computing allows for, plus it gives you access to all of the sensors and a lot of the interesting components that are available on your mobile device that's in your pocket. We believe in computational action, where people can make apps that activate change in their communities. We have 24 million people using it today, and there have been 11,000 schools every month develop apps with it. So it's used widely throughout the world and in schools and for individuals. It was part of the project at the Computer Science and AI Lab at MIT. I'm speaking to you from the Stata Center, Building 32 in Cambridge, Massachusetts. And we're celebrating almost our 15th year of mobile app development. The App Inventor UI consists of 2 different parts. There is a designer, which includes these 4 sections that allow you to select components, do an approximate layout on the screen, adjust the components in the component view, and then modify properties of every component. And then there's a code view, or the blocks editor, as we call it. And as you can see, if you've ever used Scratch or Make Code, it's very similar to using blocks and events to program your app. We're going to go through all of these and show lots of examples. How do you set up MIT App Inventor? Well, there's two things that you need to do. Firstly, you need to install the MIT AI2 companion on your mobile device, either iOS or Android, and you need to be able to log into the App Inventor IDE. So these instructions describe how to install the MIT AI2 companion on your Android phone or iOS device. You can also do it on a Chromebook or an iPad on a single device. The second thing that you need to be able to do is to log into the App Inventor IDE on a browser. Today we're going to be using code.appinventor.mit.edu, which is an anonymous login and where no personal information is maintained. If you have a Gmail account, a Google account, or a Google for Education account, you can also save your resources by logging in with the appinventor.mit.edu page. This page also includes lots of resources, including tutorials. Let's make an app. We're going to log in with code.appinventor.mit.edu, the anonymous login. We're going to skip the survey, click the Neo UI, continue, close, and we're presented with the new project screen. We're going to make our first app, a new project called First. What I always do is in the title, I make sure that I set the title of screen 1 to match the app name. It makes it easier to manage. As I showed in the slides before, the stuff on the left here are the drawers that contain all the components. This is the designer screen in the middle, and this is where the components are laid out hierarchically over here, and each one of these components has properties. So we're going to go through this a lot, and as we go through all of the apps, but the user interface in the designer is the same for all of them. This is going to be a very simple app with two components. We're going to add a button here. And for almost all UI components, I usually do with fill parent over here in the properties. And in this case, the second component that we're going to do is under media, we're going to add a text-to-speech component. Notice that the text-to-speech and a lot of these other components over here, the camera, for example, are non-visible components, so they show up down at the bottom here as a non-visible component. Let's look at these properties here. I think it would be nice, instead of having the button with the text, it might be nice to have an image in that button. So I'm going to upload a file here, the App Inventor logo. And this allows me then in the button to set the image background for that button. Because the image doesn't necessarily fill the entire screen, I'm going to go to screen 1 and align this horizontally in the center so it looks nice. That's all we have to do for the designer. Well, let's see if we can test that. I'm going to connect to the AI companion, which allows me on my mobile device right here to connect to the AI companion. I scan the QR code, and eventually the app connects to the phone. There we go. So what does it do? I can push this button all I want and nothing happens. So we have to go over to the blocks editor to actually add some behaviors. What do we want to do? Well, something very simple. We want to, when the button is clicked, we want to say something. What should we say? How about welcome to MIT App? Again, going back to the app.
Welcome to MIT App Inventor.
So I'm holding the phone, pushing the button.
Welcome to MIT App Inventor.
That's it. We're going to make a new project and call it Doodle. As usual with the every app, I like to change the title on screen 1 to match the app name to make it easier to manage. This app is going to consist of 3 components, and we're going to explore some of the options in the drawing components. In particular, a canvas. Now, as usual, I make the UI components fill parent for the width, but also in this case, I want to make it height fill parent so we can see the entire canvas on the screen. Well, let's see how this looks. So I'm going to connect to the AI companion to get my QR code. Click on MIT AI2 companion on my phone. Click the blue button to scan the QR code. And eventually, after a couple of seconds, we will connect to the phone. So here's the app. There's a canvas. It doesn't do very much. So what is it that we want to do? Well, the canvas allows us to sketch with our finger on the screen. But in order to do that, we have to write some code. So let's take a look at what code the canvas component offers us. When we drag our finger across the screen, it generates the dragged event, which gives us a whole bunch of XY coordinates. When we do that, what I would like to do is actually use the draw line procedure of the canvas. That allows us to draw a line from the previous X position and the previous Y position to the current X position and the current Y position. If I'm able to do that, you can see that now I can draw on my phone. So here it is, I'm drawing that. Well, that's not a very satisfying drawing. And in fact, I don't know how to get rid of this. So a good extra component to add would be some kind of way of clearing the screen, a la an Etch-a-Sketch. So let's go to the user interface component, add a button to the UI, width fill parent for the button, change the text of the button to clear, and this will allow us to clear the screen. Again, we have to have code that allows us to do that. So when the button is clicked, we want to call the clear procedure from the canvas. So now if I draw this and I'm not happy with it, if I click clear, I can start over. There are lots of different things that you can do with this. You can save the image, you can email it to a friend. There's a whole bunch of things that you can do with the drawings that you make. There's also changing the colors of the pen and all kinds of things like that. However, this line is kind of thin. It might be nice to have some options in terms of line thickness. So I would like to add one more component from the Use UI drawer, and that's a slider. I'm stacking these components up here, width fill parent again, and I have my button, my slider, and my canvas now in the UI. The slider has 3 different properties: the minimum value, the maximum value, and the current value. Well, if we look at the canvas, the default line width is 2 pixels here. So I think what I'd like to do is allow for the slider to give me maybe, I don't know, 1 to 10 values, something like that, and then start with an initial position of 2. So if the slider position changes, then what I would really like to do is set one of these properties, which are the dark and light green background components. I would like to set the line width to the thumb position. As simple as that. Let's take a look at how that works. Here I am drawing with a width of 2. If I move this over to sort of the middle, like 5, I get a thicker line like that. And if I move it all the way up to the max, I get a line like that. That's it. Next, we're going to do the mapping app. So we're going to make a new project and call this mapping. As usual, in the title, we're going to change the title of screen 1 to map the app name so that it's easier to manage. And over here of these components that we're going to pick, we're really just going to pick, we're going to pick a map component. So this is the Google Maps API, and it allows us to do a lot of things that you would ordinarily do with mapping. So as we usually do, we're going to do width fill parent. And in the case of a map, we're going to do height fill parent as well, so we can see the entire map. Now, what is it that we do with the map? Well, let's connect to our AI companion first. And when the UI connects to the phone, we now have the map. What can you do with the map? Well, the stuff you can usually do, you can move it around, you can pinch it to zoom. And in this case, as you can see, the maps are centered around where we are, MIT in Cambridge, Massachusetts. But the map by itself just doesn't do very much. So let's see what maps are capable of. The events for a map, there are lots of them here, but we're going to use the long press at point event to see, to do what is very typical, and that is to drop a pin, quote unquote. So the point of this app is to actually demonstrate some of these built-in components over here. The math, list functions, and in particular, variables. So we're going to make a global variable, list of pins, and we're going to name it pins. Under the list drawer, we can create an empty list because there are no pins available. Well, when we hold the button down on the map, we want to create a new pin at this latitude and this longitude. So let's do that. Under the map, there's another procedure down here which says create marker at latitude. And going back to the list drawer, what we want to do is add items to the list being pins, and the marker or pin that we want to add is at this latitude and this longitude. Cool. Let's see what happens. If I go to here, here is right here in the middle. If I hold down, this is where we are at the data center, and there's a pin on the map. Well, this pin doesn't do very much. It's just there. So maybe what we can do is get it to give us some information about itself. Say, for example, latitude and longitude. How about that? So we're going to do a couple more things here that indicate how you can use these built-in functions. I'm going to use the control function loop here for each item in list, where we're going to go through all the pins that we've created and do something for them. That also introduces this any component drawer down at the bottom here. And so for any marker, I can do a bunch of these different things. I have a bunch of procedures that I can do, and I can actually set these properties. So in this case, I would like to be able to enable the info box so I can see something. When I click on the pin, and let's just call this pin. So for each pin in the list of pins, I'm going to enable the info box of this pin. I also would like to do something with the title. So I'm going to copy paste that and select title and be able to do something with that. But in order to enable the title to show, I need to set the info box enable to true. And then down here, why don't we just show the latitude and longitude? We'll join the latitude to the longitude. And I think it would be nice to put a comma in between them so it would be easier to read. However, the latitude and the longitude are accurate to 10 decimal places, both for the GPS when you read the value off of the component. So that's a lot. In a thousandth of a degree, latitude is about the length of a football pitch. And at this latitude, a thousandth of a degree in longitude is about the width of a football pitch. So why don't we just go to 3 decimal places? For that, we can use this math function, format as decimal places. And I think I would like to do 3 places. Oops, not 32. But I need to be able to find the latitude for this component. So again, on the any component drawer, any marker, I would like to get the latitude, and the component that I'm getting the latitude from is the pin. So here I've set the latitude to 3 decimal places, and I'm going to do the same thing with copy paste for the longitude. Let's see how that looks. Another landmark, if I zoom in here, if I go across the river to Boston, and I look down here, here is the iconic Fenway Park, home of the Boston Red Sox. And if I create a pin there and touch it now, you can see that I am at latitude 42.347 north and longitude west 71.097 degrees. And here are the 2 pins. MIT is at this latitude and longitude, and Fenway Park is at this latitude and longitude. That's it. When presented with the projects page, we're going to make a new project, and we're going to call it Tilt. This indicates some of the sensors and games that you can build with this MIT App Inventor. Change the title on screen 1 to match the app name, and we're going to use 2 of the drawing and animation components. First, a canvas, which as usual, we're going to width fill parent, but we are also going to height fill parent so we can have the canvas fill the entire screen. And we are going to use a ball, which is an animated component, and put it on the canvas. You can see over here that the ball is nested inside of the canvas. So this view here of components shows you a hierarchical nesting. That ball is kind of small, so I'm going to change the property here on the designer to be 15 big, and I'm really bored with this black, so I think I'm going to pick red for my color. Cool. Okay. And then the one other component that we're going to use here is in the sensors, we're going to use the accelerometer. When I add it to the designer, you can see that it shows up on the non-visible components because it's just a sensor in the phone. Moving over to the blocks editor, what actually happens here? Well, the accelerometer has a couple of events, but in this case, we're just going to look at when the acceleration has changed. In other words, the phone has tilted. And when that occurs, what we would like to do is we would like to modify the ball X and Y positions. So if we set the ball X, what we would like to do is we'd like to take the current position of the ball and add something to it based on the acceleration. So let's go back to math. Look up here for some of the arithmetic functions, and we're going to add to the X position its current X position. So we're going to use the light green ball X position. And we're going to add the X acceleration. This moves the ball to position X from where it was before and adding the acceleration. We'll do the same thing for the Y position. And we're going to update ball Y with acceleration. Let's see how that looks. Once I connect to the phone, now I can move my phone around and do all kinds of things with detecting the motion of the phone. One more thing you could do if it's not moving fast enough for you, we could make a factor that would make it move faster. I don't know, how about a factor of 2, I guess? And then again, going back to math, if we use the multiplication block, then we could multiply the acceleration by a factor. And for X and for Y. And then now it's moving with a factor of 2, so it moves a lot faster when I tilt my phone. That's it. At the new project screen, we're going to click new project and we're going to write a story. So the title for screen 1 is also going to be story. And for this, we are going to add a couple of components that we haven't seen before. In particular, under the experimental components, we're going to be using an AI chatbot, and App Inventor warns us that this is an experimental thing. So when I drag it over here, it becomes a non-visible component. Unlike in the past, we're actually going to lay out buttons and other UI components horizontally as well as vertically. So I'm going to use for the first time a horizontal arrangement. Horizontal arrangements work best, like most UI components, when we width fill parent them. And inside of this horizontal arrangement, I'm going to create a button and a text box side by side. So you can see that now, rather than laying out the components vertically, they're laid out horizontally. Again, the text box should be width fill parent, and I'm going to leave the button at its natural width. The text for the button should say something like, tell me a story about something, and I'm going to let the person, the user, fill in what we want to tell the story about in the text box. Well, once Gemini generates a story for us, we need to be able to put it somewhere. So I'm going to take a label and put that right underneath here. And as usual, width fill parent for the label, and that's where we're going to put the story. So a couple of things about using the chatbot. We are going to use Gemini, the Google generative AI chatbot. And for that, we need an API key of AI Workshop. And so we're just going to configure things over here in the properties rather than doing them under programmatic control on the blocks editor. So how does a chatbot actually work? Well, when the button is clicked, we would like to have it tell us a story. Well, how does that actually work? Well, in the chatbot, we can pose it a question. What should that question be? Well, it's some kind of thing that's usually called a prompt. And in this case, the prompt can simply be, tell me a story about whatever the person entered for their subject area. In this case, we actually, because button 1, the text, and I'm grabbing any old getter here because I can always drop down and select the right thing. Button 1 text says tell me a story, and the text box text is what the person entered. So tell me a story about something. That will send that off to the chatbot. Well, how do we know what the result is? Well, when the chatbot gets a response, then we simply want to take that response text and put it in the label. It's as simple as that. So set the text for the label to be the response text. think it probably would be a good idea that once the chatbot returns with the result, that we also zero out the text for the prompt so that we can enter a new prompt if we want. So I'm going to set the text for the text box, where the subject matter goes, and just make that empty so that the person can more easily fill it out next time. Let's see how this works. So I'm going to connect to the AI companion to get the QR code. I'm going to click on the AI companion on my phone to find the blue button, click scan with QR code, eventually scan it, and this will connect my app. So what would we like to have a story about? Well, how about raspberries? When I click on the button, the chatbot is going to be queried about a story about raspberries, and it's going to return to us. Gemini returns to us a story about Esme. This story is so long that it goes off the screen. So this will tell us one thing that we definitely need to do. I'm going to go back to the designer, and on screen one, if we make screen one scrollable, then I'll be able to scroll my story farther down. Let's try that again. Tell me a story about raspberries, and Gemini goes away, thinks about it, and then creates a story for you. This is a really long story. I'm not sure how great this story is, but it seems pretty long. Okay, one more on the designer, one more configuration detail for the chatbot is this system, which it kind of hints the chatbot of things that it can do. So let's put in limit to 200 words and try that story again. I don't know. How about telling me a story about guinea pigs? I like guinea pigs. And great. Here's a short story about two guinea pigs named Pip and Squeak. How about changing the names of the guinea pigs? I don't really like those names. So Barnaby and Theodore. Great. Those are different ones. And again, we can keep modifying the story until we get something that we like. That's it.
Thank you so much, David, for that in-depth view into MIT App Inventor. I love how flexible it is and how the people at home watching can take that into any number of directions. I think the mapping one gave me some ideas straight away. I was thinking, you know, I'll never lose my car again if I can just drop a pin and save that. The drawing and canvas one, I really like that too. That would be, for me, a sort of note-taking app. I can imagine that being quite good. Before we wrap up though, just a quick reminder, if you want to enter Coolest Projects, now's the time to do it. You can build on what David just showed you or browse our project site at projects.raspberrypi.org for some more ideas. We've got hundreds of step-by-step guides there to help you get inspired. And as David mentioned, the App Inventor website has got a ton of tutorials to help you get started learning how to use it and to give you an idea of what you can make. If you've got any questions, please get in touch. You can contact us at hello@coolestprojects.org. Either myself or my helpful colleagues will be there to take your queries. We really cannot wait to see what you make, whether it's through the online showcase or at one of our in-person events. Thank you so much again for joining us today, and happy making.